Hey, what's up, guys? This is Cheng here. So this time, again, right? Today's daily challenge problem number 906, super palindromes. Um, okay, so we're defining like a positive integer is a super palindrome if the integer itself is a palindrome, and it is also the square. It is also the square of the palindrome. Okay, and then you're also given like a range, right? Left and right. And we need to return the number of the super palindromes, integers, within this range, right? So what does it mean? It means that, so first, this number has to be a palindrome by itself. And the second one is the square of this number also needs to be a palindrome. Okay, so for example, within the range 4 to 1000, so we will have like 4 super palindrome, which means that, um, so number 4 is uh, so here we have like 4 uh, valid super palindrome because so we have 4. So 4 itself, is a palindrome because a single number is always a palindrome, right? And this one is a square of what? Square of 2. And the 2 is also a palindrome. That's why 4 is a valid one. And the same thing for 9 here. 9 is a palindrome and it's a square of 3, right? But then if we keep going, so we have a 4, right? So for the 4 square of 4, we have what? We have 16. But 16, this one is another palindrome, right? That's why 16 is not the answer. And then we have a 1 to 1, a 1 to 1 because 1 to 1 itself is a palindrome and it's a square of 11. Right? Similarly for this 484, it's gonna be a 484 is like a palindrome and I think it's a square of what? 14 maybe? No, it's not 14. Yeah, it's a square of 22, of course, right? So that's why we have this one, right? That's why we have 4 numbers, right, within the range of 1000. Okay. So yeah, I think that's the basic idea here. Basically we need to check both. This one is a palindrome, and then the square of this one is also palindrome, right? And so the constraints is like this. So the number is like 10 to the power of 18th, which means that there will be like at most 18 digits, right? So to solve this problem, actually there's no fancy solution for this one. We simply just need to brute force all the possible numbers, right? But we simply cannot brute force all 10 to the power of 18 numbers, and then we check if the square of this number is a palindrome or not, right? Because that will obviously TLE, because this range is too much, right? And so if we look at this kind of example here, the first row, so this row is the answer we're looking for, right? And since each our answer has to be a square of some numbers, of some like palindrome numbers, that's why instead of looping through everything, it's 10 to the power of 18th. We can basically loop through the numbers. We can loop through the second line number, which means in this case, we'll basically cut our searching range from 10 to the power of 18 to 10 to the power of 9, right? Because we can simply search the numbers, right? The basically the base number, because we'll be doing like a square, right? But still, right, this 10 to the power of 9 is still a little bit too much, right? If you want to search this one, it probably will also TLE. Now how can we reduce this our search range even more? Remember, this number has to be a palindrome, right? So the number has to be a palindrome, and the search range is also like 10 to the power of 9, basically 1 to, right, 10 to the power of 9. But this number has to be a palindrome. So what is a palindrome? Palindrome is like, it has to be a symmetric, right? So which means that if we have 1, 2, 3, 4, 5, right? And then the other side we could have like 4, 3, 2, 1, right? So this is the number. This is a palindrome number, or it could be a 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, right? So this is our basic, the two possible palindrome in our case scenario, right? So which means that as you guys can see, we only need to enumerate the search range could be only cut into half one more time, right? Because it could be only we can only search 1 to 10 to the power of 5, because like again, right, since we need to have like a palindrome, if we already pass this search range, let's say for the 10 to the power of 6, right? So if we are trying to search the half size of the palindrome, right, and if we are have one more like have 6 digits to be able to form like a palindrome, we need at least five uh 5 more digits to form a palindrome, right? But the total search range is 10 to the power of 9. That's why, if we only search the half of the digits, we only need to search the 10 to the power of 5. Okay, and then with this one, we can simply come up with the concatenate or generate the entire palindrome string. And then we simply need to do once we have the palindrome string, we just need to do a square of that string, and then we check if the square of that value is also a palindrome or not. Okay, and of course we also need to check if that square value is also in the range of left and right. So yeah, so that's the basic idea. So now from 10 to the power of 18, we're reducing the search range to the 10 10 to the power of 5. Okay, because and last thing is that since we could have like this is like the odd digits case, and this is the even digits case. So which means we have to consider them separately, which means we're gonna use like 2 for loops to check both the odd and even palindrome strings here. Okay, cool. So, and like I said, we're gonna have like answer equals 0, right? So like I said, since we only need to search in the range of 10 to the power of 5, right? And then we have a string 1. Basically, the string 1 is the string of I, right? And then string 2 is the reverse of the string 1. And so for this one, let's see the check. This is the odd case. So for odd case, if we have 1, 2, 3, 4, 5, right? What do we need? We need from here we need 4, 3, 2, 1. Okay. And how can we get that? It's going to be a S1. You can use a slice, right? So if we do if we reverse everything, that's going to be this one. But if we add like trying to reverse from the last 2, it's going to be a -2 like this, right? That's how we get this 4, 3, 2, 1. Okay, and then we have the s equals to s1 and plus s2, right? So this s here is like the concatenated palindrome string here. And then we have the number. So the number will be int of s, and we do a square, right? And then we check. So if the number is greater than the right, So I see. And here the right is a string, and where the number is an integer, we can quickly convert the range into an integer. It's going to be an int, right? Left, and the right is going to be int right, So if the number has exceeded our range, we can simply break, right? Otherwise, we need to check if the number is it's greater than the left, right? Because if it's then it has to be smaller than right, because otherwise it would have already been breaked out, right? And we check if this number is a palindrome. So we can simply do like this like naive check, right? So we convert it into a string, and then we check if the string of the number and the reverse is like the same, right? If that's the case, we know, okay, we find one of our answer, okay? And that's the odd case, For the even case, we can simply copy and paste this one. I know it's a little bit like duplicated codes here, Instead, here we can simply just reverse everything, because we're doing this, right? 5, 4, 3, 2, 1. So this is the even case. Yeah, and we can just keep everything the same. Right, so keep in mind that we don't want to put everything. We don't want to put the same logic into one for loop here, because we might break in an incorrect place. Right, because in that case, we have a number. We have number 1 and we have a number 2, right? And if number 1 is greater than the right, and then the number 2 might not be greater than the right boundaries. That's why instead of checking them separately, and to avoid that confusion, we can simply have like two for loops, right? And then yeah, so we simply return the answer. That's it. Yeah, so I think that should work. Oh, sorry, this is the right. R instead of right here. Run the code. Okay, accept it. Right, submit. Yeah, so that's it, right? Cool. So as you guys can see now, the time complexity for this one will be like 10 to the power of 5, right? And then times some string manipulations, to reverse a string, this is going to be a 5, right? This one is also like what, a 5, right? Because this is also a string here. Yeah, so I would say this one is more like a 5 or 10, right? So which means you can think this part as a like constant. Cool. Yeah, I think that's it, right? I mean, I don't know what to say. I mean, this is a pure math problem, right? And the only tricky part is that we have to somehow reduce the search range, right, from 10 to the power of 18th to 10 to the power of 9, and then further down to the 10 to the power of 5, right, by using this kind of square and the palindrome. Yep, I think that's all. All right, thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.